Fantastic. Can everybody hear me okay? Great. No. So thank you very much for inviting me to talk this afternoon. Apologies for that title. It's not the greatest. I should do better next time. Something a little bit more inspiring. So I head up a team here at Ordnance Survey within our operations group. My role here is really to look at the technology stack that we've got in terms of how we collect and analyse data today and where we need to transition that to in the future. And really, I guess, enabling the organisation to do new things, and that's new things to government, who are a major customer of ours, but also new things for our sort of commercial part of the organisation. So let's forget about that. So my talk this afternoon is really looking at sort of a short summary of where we are today in terms of our customer and in terms of how we collect and analyse data, but then looking at where we think we need to be going in the future to meet our customer demand. So I should say that I do have a little bit of history in cartography. I studied at Newcastle University quite a long time ago as a surveyor, and part of that course was cartography, and David Fairbairn was my lecturer and also my, so I guess a mentor up at Newcastle as well. So I do feel a strong connection to this community. So first of all, just a quick run through of the sort of customers that we work with and serve today. So government, absolutely our biggest customer, and our job in sort of meeting those needs across the whole of government. And just like we heard, so geography, surveying, mapping across government has huge impact, but we can always do more. I think part of the challenge we've got is really sort of educating, okay, where geography, where mapping, where geospatial can have more impact within government. But we work across all of the departments, the local authorities, down to sort of district level. They all have access to our data, and that could be our sort of large-scale data, or that could be our sort of derived products, and is really used to help register land, help enable transport, help to enable sort of understand where sort of education establishment should be going. So absolutely our biggest customer. Then we move on to commercial customers. We're part of BAYS, but we're a GovCo, so we make our money through selling our products and services. So we absolutely have a strong commercial arm. Majority is within Great Britain, and sort of customers in this space are sort of the utilities to help them position their assets relative to a sort of set base map, but also sort of land and property, insurance, banking, and other types of customers. So the third area is our consumer. So I guess our sort of traditional sort of mapping products, 1 to 25,000, 1 to 50,000, whether that's paper mapping or whether that's sort of mobile, digital, online. Actually, by revenue, it's by far the smallest part of the organisation. But I'd say by impact and by what we're known for, it's absolutely huge, and it's something that is absolutely part of our core, and so important to us. And we're part of our, I guess our ethos at the moment is not just here's a map to help you understand where you are and where you need to get to, but it's also to help enable people to get outside and to improve their sort of physical and mental well-being. And we have a lot of programs and we do a lot of work to really embed that and get maximum input. So we have our customers, and then we produce, because we've got lots of customers, we need to do something. So I guess the challenge we got is putting the real world into a database and then into some mapping products, so whether that's digital mapping or paper mapping. So this is traditionally what what we're known for. So taking our building here on the top left and then putting that into the database. So this is a 1 to 1250 scale map of our building, and that is what we do. And we do that using a number of tools and techniques and skills and people and capabilities. So we have around about 230, 240 surveyors who are out there every day, updating our mapping generally with high precision GPS, so sort of 1 to 2 centimetre GPS equipment, really, really high accuracy, putting that new building, putting that new road junction, putting a new bit of park onto our mapping to keep that up to date. Alongside our surveyors, we have some airplanes, so we fly our own airplanes, and we also have some external contractors who fly for us. We fly around about a third of the country each year. To take that imagery and put it into our database, we have about 60, 70 remote sensing surveyors here down in Southampton. But we also have an external supply chain. So we have 3 companies that we work closely with, and they have 1,000 people who are manually extracting change, things that are happening, things that have been built, developed, things that have been knocked down in the environment to update our mapping. And on top of that, we have quality assurance. We have 60 or 50, 60 people in our cartography department. We have people who manage all that. That is a large workforce, sort of 1,500 people, that sort of thing. And that is pretty much fit for purpose for where we are today. And that works really well, and it's really efficient, and it's fantastic. There is a little bit of a but though, and the but is, where are we going in the future? So as a commercial organisation, we are looking internationally for opportunities. We're currently working in 13 countries. That sort of flexes up and down a little bit. But we're working in a number of countries around the world, generally in Middle East and Far East, but also in Europe and South America. And the services we have around strategy development, around helping organisations understand what geography, what mapping, what data collection they need for their use case. But going forward, our ambition is actually to help them set up that new infrastructure, to take what we've got in Great Britain and say, actually, elements of this are really fit for what you need to help collect and manage your data. So international is a small part of our organisation at the moment, but is growing substantially. And on top of that, we're looking at other opportunities in Great Britain to collect different types of data for our current customers. So utilities, for example, are coming to us and say, actually, what you give us is great, but we want a lot more from you. My children chose this picture last night. I was going, what pictures am I going to put in? Like, you've got to use that one. Okay, so I've got to now work out what a connection between the picture and a use case. So government is working closely with us through the Geospatial Commission, who are the policy arm within government, and we're working with them, negotiating with them about what types of data Ordnance Survey should be collecting for government in the future. And what major challenges does government got that could be helped by geography, cartography, and geospatial? One of those is obviously environment, but also things like food security, things like security in general, things like transport, things like, we all know, have these terms like smart Internet of Things and autonomous. Okay, so what does that actually mean? How do you map the environment to enable these new use cases? So government is coming to us and saying, actually, we want more from you. And that is a live discussion that's going on at the moment. So for me, that creates a bit of a challenge / opportunity. We'll like to look on the positive side. So currently we have some aeroplanes and some surveyors and our cartography department, and it's 1,000 people in that stone supply chain. And we also do a little bit of change detection automatically, so we can tell our people where the change is happening to help them speed up their process. But that stack that we have can't be packaged up and put in another part of the world. And that stack is also probably not fit for purpose for collecting the new types of data that we need. So we have to do different things, and we have to add on different things. And that's where it gets quite exciting. So we take what we've got currently, and then we think actually there are other data sets out there that are really useful and fit for purpose and have good quality and provenance, so we'll add those in. But also we need to collect new types of data. And we've been looking over the last year or so at numbers of techniques to do that, so sort of mobile mapping systems, drones, using the crowd, satellites, other things up in the air. And then once we've got that data, how do we extract the content from it? How do we make it actually useful? And our focus is going to be increasingly, actually, we need to be focused on automation first, and then manually improving and updating, and where we can't automate the process. Because if we go into a country, we cannot take what we've currently got today. So I thought it'd be interesting, hopefully, better than my title anyway, to go through a few of those examples. So the first one, as was mentioned earlier, is a project that that's been running for about 5 years now, and we sort of went in February and went public with it, which is a platform called Astigan. So Astigan is a drone. It will fly up at 20,000 meters for 3 months at a time. It will have a wingspan of 38 meters to be determined, and we'll take pictures. And we'll use this as a highly efficient way of taking imagery. So currently we've got airplanes. We think we're going to need satellite data, but this is sort of a middle ground. So in the middle of the wing, we'll have a camera, and that could be red, green, blue. It could be hyperspectral. It could be a synthetic aperture radar. And we will take this platform and use it as a highly efficient, automated way of capturing different parts of the world. So that's an addition to aeroplanes, so taking from the air. Our customers are also coming to us say, actually, we want more information at the street level. So we can do that in a number of ways. We can work and build our survey workforce to do that. We can drive around the streets with a mobile mapping system, and they'll work perfectly. But this is one of the projects that we've currently got, which is looking at actually how we could do that in an automated way. So this is a partnership with a company called Mobileye, which is Intel, part of Intel. And they have really small, not massively accurate cameras that they put in vehicles. They've got hundreds of thousands of these. Take a live feed of imagery, and then they interpret what they've seen. And that interpretation for Mobileye is really around safety. So is the car just about to hit something or somebody? And to give that driver that information. But we've been working with Mobileye to augment that sort of machine vision algorithm to actually say, instead of a person, that's a manhole, or that's a street light, or that's a street sign. And then to extract that from the system and then populate a database. So this gives us a way of harnessing a crowd to populate our database. Now this is a project that we don't know where it's going to go, but it's just something that is interesting, and we'll see where we end up. But really, what the camera sees and interprets is on the left there. So it sees a sign or a manhole or whatever, but that is relative to the car, So in a sort of relative coordinate system, so as the car drives along, it's sort of, we don't know where that thing is. So our part of the partnership is to then put that into our database. So what we do is look at what the system's found, see where we can get that same piece of information either within our mapping or from our aerial imagery, and then match the two together to come up with something that then goes onto our coordinate system. So what we end up with is a load of assets in a coordinate system that we can work with, and then that can go into our database. So very much work in progress, but we'll see where that goes. Another thing we're doing is some of our customers want us to come up with, as I say, more detailed view of the street, but also a 3D view of the world. And we can, again, get that from aerial imagery, but we can get that from a number of sources. So things like LiDAR on mobile mapping systems, that works really well. That will do the job. That's very expensive. So that's at the £50,250,000 sort of level to create a sort of a LiDAR-based map just to buy each bit of equipment. So that's good, but this is a terrible picture. But I guess it's not meant for us, it's meant for a computer. So what each of the green blobs on the left is where an image has been taken, and then that image has been interpreted and been used to create a colorized point cloud. So each one of these points has a coordinate and an association as to sort of what it is. We can interpret what it is. But we've done this using a mobile phone. So we can drive along with a mobile phone, somebody in a passenger seat or mounted, take lots of pictures and create a point cloud pretty much for free. It has, it's not as accurate as a £250,000 survey mapping system. In most instances, actually, it's fit for purpose. So we can then take that point cloud and then interpret it and say, actually, this is supposed to be a wall, and there's some houses up there with windows and doors, and there's a verge there. But then we can take that 3D point cloud and put it into a bit of software that is pretty much off the shelf, and then create a 3D model. So from just driving around, taking like a little bit of video, we can then create a 3D model. So that's useful and interesting, and I'm getting the sign that I've got 2 minutes left. So probably the last thing that we're doing is using techniques like machine learning and deep learning that I'm personally not an expert in, but I've got an amazing team that are, thankfully, to train computers to interpret the landscape. And you can do that in a number of ways. You can either say, this is a rule set, there's some training data, this is what we found in the past, we'd like you to find something in some new imagery. Or you can train a computer using some deep learning techniques to identify certain things, and then from those certain things, it then works out what it wants to see, and then you interpret what it sees, which is a bit crazy, but it works, which is quite cool. So all these blobs are what we've extracted using some automatic techniques. So we've used some satellite imagery, we've used some OpenStreetMap data, we've trained it on some master map data in the UK, done a bit of hand labeling, and then this is, I think this is Ghana or Guyana, one of the two. We've automatically created a product, it's called a product, for probably a computer, of where all the buildings are. And then it's also said, actually, we're not too sure about these things, we'd like you to check them. So if you've got that, you can then say, this is vegetation, this is water, this is road building, this is a impervious surface, and you can start to very quickly work out what that sort of land cover world looks like. It's not perfect, but as an offering into the international space for a country that has mapping that is probably maybe out of date, or they don't have anything, it's a good start from which to build from. Got 2 more slides.
That's fine, that's fine.
Okay. So once we've identified that some things are building, we can then look at our mapping and say, actually, there's a building here, what's in your database, there's a difference, therefore that's changed, therefore that should go into your feature extraction process. So this is what's happening at the moment. So our remote sensing surveyors have a view as to where the change is. They're not just looking at the whole image. But we can get more automated. And then the last slide is using some deep learning techniques, interpreting, this is quite a fun task, interpreting what the computer has seen. So we say, here's an image, what do you see, computer? And it says, here, there's a load of stuff, and then we can interpret what it's seen. So sometimes it's really, really bad, and it's rubbish at seeing some stuff, but in some instances, it's really, really good. And the trick is to work out where the good stuff is, and then to take that and say, actually, that's an early version of content, and then we'll build on top of that. So what it's really good at, seemingly, is working out where the solar panels are. So we can use deep learning techniques to identify roof shapes and orientation, and then we can say there's a solar panel on there. And then, well, that could be interesting for some of our customers. And that is, once we've set it up, a completely automatic process. And what the trick is now, working out what we need to do manually to make that fit for purpose for the customer. So I shall finish on the challenges. So from where we are today, we need to be in a different place because we've got a different customer base. That will be based more on automation than we currently are. But there's still a long way to go. So refining the methodology, working out how we scale that to an international setting in a part of the world that we have no experience. Assessing the quality, for me this is the biggest challenge. And then how we represent the outputs. So the outputs are generally for a computer, but then if you've got a basic mapping product of a part of the world, how do you actually introduce some of the contextual information to make it useful as a map? So a very quick run through, and yeah, I don't know if there's any time for questions.
Yeah.
Paul.
Great. Well, thank you for some quite intriguing insights there. We've certainly got time for a couple of questions, and I guess you'll be around at lunchtime if people have got further things they want to ask. One right at the back there, Steve.
If I understood you correctly, you were saying that you're using OpenStreetMap for validation of LIDAR data. Can you give us an instance or circumstance where that might be appropriate?
So we've used some OpenStreetMap, I guess, in a research setting to look at how we can develop a training data set for our machine learning algorithms. So we don't have any information or mapping in some of the parts of the world where we're having conversations. But some of that data does exist. And so to work out whether the tools and techniques that we're developing are actually going to work in that country, we need to do some research. So we're sort of using as many sources as we can. And so we're using OpenStreetMap in that context. How we use it in a production context, I don't know, but it feels like it should have a place, definitely.
Anyone? Oh, second one.
Sorry, we hear a lot about drones and the problems with airplanes and airports.
Yeah.
What restrictions do maps just on the road put on what you can do with that rather simple-looking big drone in the field?
So what do they?
What restrictions do maps being traffic control?
So currently we can't. The only place we can fly the big thing, Astigan, are in ranges. So we fly it in a military range in Wales, or we fly it. We've flown it in Spain and in Australia, where we can get permissions to fly within the air column. So basically nothing else enters that air column when we're flying. The whole aspect of high altitude platforms is one that is growing, and there are a number of companies out there. There's competition for this, but there's also people who are developing airships and balloons for altitude. And this sort of technology is called HAPS, so high altitude pseudo satellites. So HAPS is an absolutely growing area, and we're all working with the Department of Transport and NATS and CAA in the UK, but also internationally to develop the sort of the legislation and the rights to fly this. My gut feel is in GB. It's challenging, but we'll get there. But we'll probably get there faster to fly commercially in other parts of the world.
Right, one to sit front.
It's one really obvious question, but do you know when Ordnance Survey master map is going to be released as open data?
Whoa! I wasn't ready for that one. Okay, I'm going to give you the obvious political answer.
Yeah, of course.
But I'm personally not part of that conversation with government, the Geospatial Commission. I can get you an answer, and I'll get somebody to come down lunchtime if that's useful. But,
Okay.
yeah, but I honestly I'm not part of those discussions, so I would just be making something up, which probably wouldn't be appropriate. So.
All right, Paul, thank you once again. Let's show our appreciation in the usual way.